Hi everybody, today we are starting a new chapter. So we're going to be looking at lesson 4.1. The title of the lesson, what is the correct dose? Let's go ahead and read the specific objectives. Students will understand that the units found in a solution may be used as a guide to the operation required in the problem. That is, factors are positioned so that appropriate units cancel. Units provide meaning to the numbers they get in calculations. Students will be able to write a rate as a fraction, use a unit factor to simplify a rate, and use unit conversion to help determine the factors in a series of operations to obtain an equivalent measure. So basically today we're going to be doing working with units and do some unit conversions. So let's begin. Problem situation number 1. Acetaminophen is an over-the-counter medication that is commonly used for the relief of headaches and other minor aches and pains. It's available in a tablet, capsule, liquid suspension, and IV form. The common adult dose is 500 milligrams to 1,000 milligrams with a daily recommended maximum of 4,000 milligrams. Milligrams will be abbreviated as mg. When medication is given as a liquid suspension or IV, it's important to understand the correct dosage that must be administered to a patient. Inability to calculate the correct dosage can result in insufficient amount of medication be administered to a patient to be effective, or it can result in overdose, which can lead to liver failure and result in death. Below are examples of children and infants acetaminophen. Acetaminophen is the only medication approved to use in treating baby fevers. Figure number 1 and figure number 2. So here different pictures of over-the-counter acetaminophen, and these are some of the drug facts that you can find on the side of the container. So we're going to be looking at the infant's acetaminophen and the child's acetaminophen. Now, as of a few years ago, the infant's acetaminophen is no longer sold. So the only one that you can find is the children's acetaminophen, which does include information for infants. However, we use this example as a way to understand how medication can be administered and what does it mean in terms of when we talk about concentrations. So look at question number 1. Let's look at it. It says, what difference do you notice between the two acetaminophen products? So can you write a sentence describing, or 2 sentences of how are they different? I'll give you a moment. You probably noticed that the infant acetaminophen, it's a different amount of milligrams. Oh, I'm trying to highlight a different color right here. It's a different number of milligrams, and it's also a different number of milliliters. Now, you might understand what that means, but we want to explore it deeper. All right. So what are these? I mean, these are called concentrations, but what does it mean in practical terms? Okay, so what do we notice? Concentrations are different. All right, let's look at the second question. Table 1 below lists the recommended dosage for acetaminophen for infants and children. Using the chart, answer the following questions. Okay, by the way, this is information. It's just for the purposes of the lesson. Disclaimer is not to use it for when you are making any personal life decisions. Okay, so this is just for our class. Okay, now let's look at question number part A. How many milliliters of children acetaminophen should be given to 8-year-old child? Okay, so I'll just highlight you the information from the chart. Okay, and it's asking you how many milliliters is given. All right, so the information that you have is that you got 320 milligrams All right, and we're giving the children acetaminophen, and the information here that we can copy is that the children acetaminophen is administered so that there are 160 milligrams in 5 ml. And when it comes to a child's dosage, you probably notice, and including adult dosage as well, you have a little kind of like a cover, a cap, and inside that, it would have one thing that would say 10, the other one would say 5, and then you just pour it and you give it to a child. All right, so now the question is how many milliliters to give. So I'll give you a moment to answer that question. Alrighty, so let's review. So here the numbers were chosen to be nice. Okay, so the way we can understand this is that you have basically 5 ml. Let's make this just bigger like this. The 5 ml of liquid right here. Inside that liquid, you have this drug, acetaminophen, that's being dissolved, right? It's mixed over inside. So inside, you'll find 160 milligrams of the medication. That's what it means when we say there are 165 milligrams in 5 ml. So since we need to give 320 mg, well, that's exactly twice, correct? So if you go ahead and give another 5 ml, that will give you another 160 mg. The total will be 320. So if you add these two together, that will be 10 ml, correct? So that's how much medication we should give to that 80-year-old, 10 ml. Okay? If the concentration is 160 mg in 5 ml. Does that make sense? All right? So now, if a parent, let's say it happened to be, as it was maybe 5 years ago, back in 2016, 2017, let's say if you were able to find an infant acetaminophen at home instead of the child acetaminophen, then you want to give it to a child. I mean, it still contains acetaminophen, so we can give it to 80-year-old, but we need to give the correct amount. All right, so what information should we bring? Well, it does say that an infant dosage, an infant one, which is right here, contain 80 milligrams in 1 ml. 80 milligrams in 1 ml. All right. We would like to give this child 320 milligrams of medication. That's what's recommended for the 8-year-old. 8-year-old. Then how much would it be? How much ml should we give to the 8-year-old child? Okay, so I will give you a moment to figure this out. Alrighty, so let's go ahead and review. So look, if you have seen some of the medications that are given to an infant, you will notice that it looks like a syringe instead of a cup. So there's a little syringe that usually goes up to 5 ml. So it has 1 ml, 2 ml, 3, right? So it's 1, 2, 3, 4, 5. Okay, so a little syringe that you push, you give it to a child because it's easier to administer, especially if it's an infant, right? Then 1 ml of that medication, okay, that 1 ml, that amount, right? 1 ml contains inside 80 milligram dissolved. So you have 80 milligrams dissolved in that 1 milliliter of solution. You want to give that child, the 8-year-old, 320 mg. Well, if 80 milligram is 1 ml, then you can count, right? So you got 80 is 1, then another 80, that's 160, another 80, that would be 240, and another 80, that will give you total of 320 mg, right? So how many mLs it is? 1, 4 altogether. So the answer would be 4 milliliters. This is a very important result. Look, both versions of the same drug, right? Child, if the correct dosage is given, is receiving 320 mg. However, when we give the child acetaminophen, which is, by the way, still available in the pharmacy, you'll give them the cup and that's it, 10 ml, and they administer medication. They drink it and they're good. Now, if when we're giving the infant acetaminophen to that child, okay, then the 4 ml is enough to administer the same dosage. And that is very important, because what if we mixed it up? What if we mixed it up and say, oh, well, doesn't matter, infant or children. And you say, okay, you're used to giving a child 10 ml because, that's what the dosage is for children acetaminophen, right? You give 10 ml, but you mixed up and you give 10 ml of this. What happens when you give 10 ml of this one? Well, if there are 80 milligrams in one and you give 10 ml, you're giving a child 800 milligrams of acetaminophen, which is an adult dosage to an 8-year-old. So instead of giving 320, you ended up giving 800, which is more than twice the amount. That's dangerous, right? So here the difference is that one of them is more concentrated than the other. Think about this. If this right here says 160 milligrams per 5 ml, what that means, which we'll write it, soon as well, we'll see it in different scenarios. If there's 160 milligram in 5 ml, you can write this as something that we call a rate. All right, it's a rate. And that rate can be reduced. So if you divide 160 by 5, you're going to get 32 mg in 1 ml. These what we call equivalent rates. They both represent the same thing. Okay, but now, by converting them in something that's called a unit rate, this is called a unit rate. Unit rate meaning it's the amount of substance in 1 ml. Then you will be able to compare this concentration to this concentration and see that an infant concentration is much stronger. Okay, we'll come back to this and we'll see if you retain that idea. All right, so let's go. Here we say that we're going to talk about a unit conversion. So a unit conversion is a method of setting up a problem that involves converting between different units of measurement. It also called unit analysis or dimensional analysis. Many healthcare professionals, including pharmacists, dietitians, lab technicians, and nurses, use unit conversion. It's also useful for everyday conversion in cooking, finances, and currency exchanges. Many people can do simple conversion without dimensional analysis. However, when presented with more complex problems, they'll often make mistakes. In healthcare situations like calculating dosages of medicine, mistakes can be very serious, even fatal. Doctors and nurses rely on dimensional analysis to check their calculation. The advantage of using unit conversions is that it is a way to check your calculation. It is always important that you develop your own methods to solve a problem, but in this case, you're encouraged to learn that particular method. Once you have learned dimensional analysis, you can decide when to use it and when to use other methods. All right, so the next question will walk you through the unit conversion process. All right, so you want to know how much medicine should be administered to a 9-year-old child who weighs 65 pounds. The medicine comes in a liquid form, and you will measure it in teaspoons. The children's concentration is 160 milligrams per milliliter, and each teaspoons hold 5 milliliters of liquid. So the way we're going to set it up is we want to know how much of the teaspoon to give. So the teaspoon is what is going to be our targeted unit. All right, so we want to know how many teaspoons to give, how much medicine in teaspoon to administer. And the way you're going to begin with your targeted unit, and you're going to write it as a rate. Okay, so you're going to write that as 1 teaspoon over 5 milliliters. So that's going to be your first step. Your next step is to convert and to get rid of the milliliters. All right, because the question is how much of teaspoon to give. Well, we know that there are 5 milliliters contains 160 milligrams of the drug. So that what you do, you write this information as a rate. So look, before we saw it written like this, but when we set up unit analysis, you can also write it like this, and that will still be equivalent ratio, like it's telling us that 160 milligrams is equivalent to 5 milliliters. So whether you write it one way or the other, it doesn't matter. But when you're using a unit analysis, your goal is to cancel that unit and end it up only with the targeted unit that you're looking for, which is teaspoon. Okay, so you write it as a fraction, 5 milliliters over 160 milligrams. So those units are going to reduce. And now you're only left with the how many teaspoons are, how many milligrams in each teaspoon. Well, you're looking at a child that weighed 65 pounds, and from the chart, the one that weighed 65 pounds, it's recommended that you use 400 milligrams, you give the 400 milligrams of the medication. So 400 milligrams is put in such a way that the milligrams will cancel as well. You see the units across will cancel. And once you get all of this, then how do you multiply a fraction? You multiply it across. You multiply 5 with 400, I'm sorry, so that will give you 2,000. And then the bottom will be 5 times 160, which is 800. And the only unit that's left is the teaspoon. All right, so you got 20 divided by 8, which is 2.5 of a teaspoon. So here we go. Now, is there some other way that you can approach this instead of the unit analysis? Yeah. So an alternative way is to write down all of the information that you have. So you got 1 teaspoon is what? 5 ml. We also know that there are 160 milligrams contains 5 milliliters of medication. All right, or in 5 milliliters of medication, you find 160 milligrams of acetaminophen, and you want to give a child 400 milligrams. So, is there a way that you can walk through this without unit analysis? You could, but then things can become a little bit more complicated. Okay, so one thing that you could do is to simplify some of the rates. Like this one was already simplified, it has 1, so we're going to leave it like that. But 160 milligrams per 5 milliliters can be reduced, okay? And we did it earlier, to 32 milligrams in 1 milliliter. Okay? So then you have to kind of go backwards. So if you want to know, okay, how many milliliters to go, how many milliliters there will be in that you need to administer, well, what do we got? We got 400 milligrams, and then you want to go this way to the milliliters. So if there are 32 milligrams in 1 milliliter, then how many milliliters will be in 400? Well, you got to take 400 and divide it by 32. 400 divided by 32 gives us 12.5 milliliters. All right, so how many teaspoons is that? Well, 5 milliliters is 1 teaspoon. Another 5 milliliters, it's another teaspoon. And 2.5 milliliters is exactly half of a teaspoon. And then you got the total of 2.5. Harder. That's why the unit analysis could be helpful, because the unit analysis, you don't really look at the what each unit means. You look at the setup. All right, and a setup is you start with the targeted unit, and then you cancel everything until you end up with the teaspoon. So let's check this out, that same analysis, but using an infant concentration. So question 4. So let me write you the information, and then I'll give you a moment to compute it. Right, so we have 1 teaspoon contains 5 milliliters. All right, Then the infant concentration, if you remember, is that there are 80 milligrams in 1 milliliter. All right, and then what we have is that it's the same child, so we need to give 400 milligrams as a dosage. So you want to put it all together, all of this, in something that looks like this, that will end up with the teaspoons. All right, so I'll give you a moment to think about it. Alrighty, so how does the setup is going to work? So you start off the same way. 1 teaspoon contains 5 milliliters. So you write it as a rate. Times. You want to get rid of this unit right here. Alright, so you use the unit right here. You know, this information is already being used. Okay, so that's your first rate. We got it. Alright, so that's done. Next one is we need to use these milliliters, and that will convert milliliters to milligrams. So what do? This is an important step. You're going to put milliliter, not across, but cross from that. So they could cancel. So that unit will be on the opposite side of a fraction. And then the milligrams is going to go on the bottom. So that's that unit. That's going to convert that. So that basically tells us how many milligrams are in each teaspoon of the medication. So it converted from milliliters to milligrams. And finally, the 400 milligrams is going to go in a numerator. And then you can put over one dose or one whatever, because it's just 400 mg. And you put it on top so that you can then cancel this unit. And then you'll end up with what you have. All right. Okay. So then if you multiply it across, you get 400 on the numerator, and then you get 400 in the denominator. All right, so what does that mean? This would mean that we're only giving 1 teaspoon. All right. So now, question is, we're giving less of the drug in terms of the amount to of the infant formula versus the child's formula. It gives you the same amount of acetaminophen, which is 400 milligrams, but the children dosage you got to give 2.5 teaspoons, while for the infant dosage you're only giving 1 teaspoon. So now the question is, looking at those two, question number 5, asking to compare them. So how do they compare? 2.5 teaspoons, how does it compare to 1 teaspoon? I'll give you a moment to sort of pick a choice in terms of the comparison. All right, so let's review. We say that infants concentration is, actually, which one is more? The child's, right? The child concentration is more. So fine. The child concentration is, you got to give 2.5 more. So we're giving 2.5 times as much medication to a child. So what that means is that the infant's concentration is 2.5 times stronger than children's concentration. And the reason is because we're giving less of an infant amount, but it gives us the same amount of drug. So it's 2.5 times stronger. You might say, well, why to give an infant is stronger than the child dosage? Well, the thing is, try giving medication to an infant. It's almost impossible. You have to hold an infant a certain way, and then you have to kind of put that medication in the mouth in a way that the infant wouldn't spit it out. So it's complicated. So that's why the smaller you give, the easier it is to administer. So that's why you kind of, they're making it stronger. okay, which is of course now also becomes dangerous, because then you have to understand that depending on the concentration of the drug, it might have the same amount of liquid in it, but it administered a different amount of medication. So as you can see here, 1 teaspoon administered the same amount of drug as 2.5 teaspoons of the weaker concentration. All right, so it's big ideas here, big ideas, and the math is using something that we call unit analysis. All right, let's do a little bit of more. I understand conversions can be complicated, so we're going to do some of these conversions that are one-steppers, or maybe two-steppers, just sort of see how it all works. So here you have some common conversions that I use between mass and volume. Okay, and we asked to convert, let's say, 12,000 micrograms to grams. Okay, so we can go ahead and highlight the unit that we got. So micrograms to a gram. So we have this to that, and then this to that. All of these, by the way, are what we call unit rates. Unit rates. They all have unit. You see, all of this is 1. All of this is 1. So that means the unit rates can be done in a little easier fashion. But first, let's practice the unit analysis. So if we want to convert 12,000 micrograms to the gram, the goal is to basically start with the gram and see what do we know about 1 gram. Well, we know that 1 gram contains 1,000 micrograms. Okay, so that's, milligrams, I'm sorry, milligrams. A 1,000 gram contains 1,000 milligrams, and then we also know that that 1 milligram contains 1,000 mcg, smaller unit of mass. And then we have 12,000 mcg that we want to convert. Can put it over 1. So now what happens is mcg cancels, mg cancels, and we ended up exactly with the grams. So then we multiply across. So we got 12,000 over 1 million. All right, so then we cancel. So it becomes 12 divided by 1,000 becomes 12 thousandths of a gram. All right, so that's one way to do it using a unit analysis. All right, so that might look complicated to do. So if you want an alternative way to do this, there's a way to go. So look, whenever you are in this table, if it's just if it's a unit rate, if you go from, so look, when you go from, let's say, grams, or from kilograms to grams, this way, you multiply. So 1 kilogram is 1,000 grams. 2 kilograms is 2,000. 3 kilograms is 3,000. So when you go from left to right, from where the 1 is, you multiply by 1,000. If you go backwards, you divide by whatever the number is. So for instance, if you want to convert from pounds to kilograms, this way, you're going to divide it by 2.2. So for example, if you have 4.4 pounds, that will be 2 kilograms. You divide it by 2.2. Alrighty, so that's a great way to do these questions. Okay, when you go to the right, from 1, you multiply. When you go backwards, you divide. Alright, let me make it neater. This way, you divide. Well, the other way you multiply. So let's do it for this question. So we have micrograms, right? And we want to go to grams. So that means we want to go from here to here, right? So we're going to take 12,000 and we're going to divide it by 1,000. So check this out. 12,000 micrograms divided by 1,000. That will give you 12 milligrams. All right. Now you want to go from milligrams to grams, because that's what the question asks us to convert, right? So you first went to this way, now you're gonna go that way to get to the grams, and it's again from right to left, so we gotta divide it by 1000 again, and that will end up with 0.012 of the grams. All right, same answer. All right, let's do the next one. Converting pounds to kilograms. So this one is quick. This is a one-step conversion. All right, so I'll give you a moment to do it. Alrighty, so if you do it using a dimensional analysis way, the dimensional analysis basically starts with your unit, which is kilograms. So we need something that unites kilograms and pounds. Well, we know that 1 kilogram equals to 2.5 pounds. So the way then you write this, since the kilogram is our targeted unit, we put it as 1 kilogram divided by 2.5 pounds. We're going to multiply by 160 pounds, because that's our conversion, right? Over 1. So then that cancels, and then you multiply across, you got 160 over 2.2 kilograms. That means it's a division. So 160 divided by 2.2 gives us about 72.7 kilograms. As you can see, it looks a little harder, don't you say so? So an easier way to do it, especially when it's a one-step conversion, it's right here. You see, you have a pound and a kilogram. So if you want to go from pounds to kilograms, then meaning you go from right to left in that table. When you go to the left, from pounds to the 1, you will be dividing by 2.2. So you got 160 divided by 2.2, and then you immediately got the same answer. So once again, when you go away from 1, you multiply. For every 1, there is something, so you multiply. But when you go back to 1, you divide. All right, so let's try this one out. Convert 2.5 liters to ounces. Okay, I'll give you a moment. So if you set up the unit analysis, so we know that so we need ounces and liters, right? So what do we have? We know that 1 ounce, which is our targeted unit, right? That's what we want. 1 ounce equals to 29.6 milliliters. All right, and we also know that, because we need liters, we also know that 1 liter is 1,000 milliliters. And then that's it. That's it, because then liters is what we have to convert. So the way you set it up, look, using a unit analysis. All right, so we got 1 ounce is 29.6 ml. Then 1,000 ml is 1 liter. So that way ml cancels. All right, and then we have 2.5 liters, which is given to us over 1. And then we can cancel that out, and then we can multiply across. So 2.5 multiplied by 1,000 will be 2,500 over 29.6, and this is going to be in the units that we want, which is ounces. So 2,500 divided by 29.6, that gives us 84.5 about, and this is ounces. All right, the other way to go, if we wanted to convert this, is to go directly from the unit what we want and the unit that we sort of want to get. So look, and for many of you, you might find this easier, and I'm not telling you you have to use unit analysis. You will have some question that you have to understand that when you do this, the units cancel. Like, how does the cancellation go? But overall, what you want to be able to see is the that in order to do conversions, you have to understand that there are different representation of the quantity using different units. So for part C, you could go without unit analysis. So you ask to convert liters to ounces. All right, so let's find liters in the table. All right, and ounces. So we have liters here. We have ounces here. The ounces are connected to milliliters, and liters are connected to milliliters. So it's kind of good. right? So what do you want to do? You want to go from liters, so that's what's given to us, right? So we want to go from liters to milliliters, and you want to go it this way, which is you want to multiply by 1,000. So 2.5, which is given to us, liters, multiplied by 1,000, give us 2,500 milliliters. You see, we got to this point. Now we have to go backwards from milliliters back to ounces. Here you got to do the division. So you're going to take 2,500 and you're going to divide it by 29.6 because you want to go backwards. And then we get 2,500 divided by 29.6, and that gives us 84.5 ounces, which is the same answer. You understand? So once you go one way, you multiply, the other way you divide. And if there's more than one step conversion, you look at that table more than once. All right, let's take a look at a different question. It says Tums, an anti-acid medication, is available as 0.5 gram tablets. Doctor prescribed 1,500 milligrams of this drug. How many tablets is this dose? Okay. How do we go? Well, let's write down the information. We got 0.5 grams is in one tablet. We want to give 1,500 milligrams. And in order to figure out that, we basically want to know how to convert from the milligrams to the tablets. But in order for us to get to that point, we need to figure out how many milligrams are in 1 gram. Well, from the table, 1 gram equals to 1,000 milligrams. So if you have this information right here, okay, can you go ahead and find out how many tablets to give? I'll give you a moment. Okay, so if we review this, one way to go this is to set up the unit analysis, which is 1 tablet contains half a gram of medication, where we know that 1 gram is equivalent to 1,000 milligrams. The reason I wrote it like this is so the gram can cancel out, and then 1,500 milligrams is our dosage. So then the milligrams cancel, and we end up with the tablets only. So you multiply it across like this. You multiply, so it's 1,500 over, you multiply this, that's going to be 500, and then you divide and you get 3 tablets. Okay, if this is if this does not make much sense, then you can go ahead and use the more conceptual understanding, and that is, okay, we're given milligrams, right? That's how much was the dosage. So then we know in order to go to the grams, this way, we got to divide it by 1,000, since we're going backwards. That would be 1.5 gram of the medication. But then for 1 tablet, you have 0.5 grams for 1 tablet. So that means if you want to go backwards to the 1, whenever you go to 1, you're going to divide it. So you take 1.5 and you're going to divide it by 0.5, and that will be 3 tablets. Right? Because 1 tablet is a half, so 1.5 grams will be 3 tabs. It's not straightforward. Okay, but especially if you're interested in healthcare, then that is the way to go. That's a good way to set it up, because it's always, the units tell you where to place your stuff. Okay, one more. Let's do the last one. Suppose a doctor has ordered 0.1 gram of medication. The drug comes in a solution concentration of 2,000 milligrams per milliliter. How many milliliters of this solution is required? Okay, so let's write all the information again. We have 1.1 gram that was prescribed. We have a concentration that says there are 200 milligrams in 1 ml. and we want to know how many milliliters it is. All right, so in order for us to get to here, we need to know the relationship between grams and milligrams again. Well, we already used this. So the question is how many ml? So pick a choice in terms of setup of how the unit analysis would work. And let's review. So the question is how many milliliters is required? This is the unit that talks about milliliters. So the idea of the unit analysis is that you start with that unit and you put it over whatever is given to us. Is that 1 milliliter contains 200 milligrams, just like the acetaminophen question, right? How many mLs? Then what you want to do is you want to get rid of this. Well, this gives you information about relationship between milligrams and gram. And when you put it in your fraction, you want to put it in such a way that the units that are across from it will cancel. You see, the idea is to cancel those units. This is the arithmetic kind of idea, is that in order to cancel something in the numerator and denominator, they got to be the same. And finally, to cancel the grams, we know that the dosage was 0.1 gram. So you put it like this, and then you can multiply across, and you get 100. You multiply this times this, you get 100 divided by 200. This is an ml. So you simplify, and you get 0.5 ml. Alternatively, to answer this question, you can go ahead and do the conversion more informally. So you have 0.1 gram of the medication, okay? And you know that 1 gram contains 1,000 milligrams. So that means you want to multiply it by 1,000. So 0.1 multiplied by 1,000 gives us 100 milligrams. And then if you want to go from milligrams to milliliters, since you go backwards to 1, that would be division by 200. So you'll divide it by 200, and you'll get to the same step. So what we're doing right now is called the unit conversions and the unit analysis. There are some supplementary resources that are available on my Open Math for you to try. And then we'll continue kind of working with the units throughout this chapter. Okay, so don't get discouraged. We will have an opportunity to do more examples with conversions. And on that, we'll finish our lesson.